What do you got there?
Grape.
Give me a grape.
You can eat with the skin
Yeah,
and no seed.
of course. I'm not going to peel a grape.
Sorry?
I'm not going to peel a grape. A few weeks ago I posted a video called Annoying Beep Beep Beep, and in that video I observed an asteroid occultation with some guys. You guys just driving past out there. Hang on. There she is, look at that. It's Yuko leaving. Yeah, I observed this asteroid occultation with some guys from the astronomy club, and that's where an asteroid passes in front of a star. And by measuring the time at which that happens from different locations, you can work out stuff about the asteroid. And you can actually get better data than they can from, the Hubble Space Telescope. Seriously. So I haven't actually shown the results of that. So this is what we got. So here's the results of our observations. These lines here represent different observers. So that line represents me. That's someone else, and so we had 6 different ones. And what happens is the gap in the line represents the time that the star disappeared. So, for example, for this person down here, it only disappeared for a very short time. For people up here, it disappeared for a longer time. So that represents about, well, for me, for example, it was about 12 seconds. So that represents 12 seconds. And because we know the speed the asteroid's moving, that's very easy to calculate. We can, use those times and translate them directly into kilometers, meaning the size of the asteroid. So from that we can determine how big the asteroid is. And if we have several observers in different places, we can get the shape of the asteroid. So as you can see on this diagram, this is the approximate shape of the asteroid. Now this part here, we're just guessing that. We don't really know that part, but it's roughly this shape. And we can tell from that data that the asteroid is about 150 kilometers across. Now the reason I am bringing this up today is because there's another asteroid occultation happening tonight. The thing is, with this one, I'm 4 kilometers from the 1 sigma zone. That's jargon. That's technical talk. And what that basically means is, I probably won't see anything. It means I'm a long way from the predicted center of the path where the asteroid, where the occultation will be visible. And even if I do see something, it'll probably be very quick. The maximum length for this one is, I think, about 1 second, and that's if you're right in the center. But regardless, these observations are valuable. Even if I report that I didn't see an occultation, that's still valuable, because that that provides data about where the shadow path actually went. So it's all good. Well, I've set up my telescope now. There it is. I've got a little table there. I'm going to put my equipment on there. I'll put my laptop and my timing equipment and recording equipment. Sounds like I've got a lot, doesn't it? It's just a little tiny recorder. The moon. Trust me, I'm an astronomer. Well, I really didn't expect to see this occultation tonight, but I did. The star disappeared. It was less than a second, I think. Now, of course, I did it in the dark, so I couldn't really video it. But here's a reenactment that I did immediately afterwards. Gone. Back. Wow. Well, there you have it, the reenactment. Now, I've just put the sound file into my computer. So there you can see where I said gone, and that's where I said back, and these are the time ticks. So what I will do is this is roughly what I will do. I'll do it in more detail later, but highlight that section from the beginning of each of my voice calls there, and then I come down here and it tells me that is 0.785 seconds. And I'll do a similar thing to measure the time from the time tick to the voice call. It's very exciting.